other life forms from 3.8 billion years ago up through to the present.
Okay, we'll look forward to it then. Thank you. Earth's first life, right?
Well, in Chapter 9, we covered the origin of life and the characteristics that are necessary for that. What I'm doing here in Chapter 10 is taking you from 3.8 billion years ago when life was first created by God right up to the present, although I'm saving for Chapter 11 the history of advanced life, life that is soulish in nature, the birds and mammals. So this is looking at the history of physical life, literally from the beginning 3.8 billion years ago up through the present. And this is the longest chapter in the book.
Okay. I should say, if you're going to name every creature that's ever existed.
No, we don't quite do that.
Not going to do that, okay.
But
an overview of Earth's history, yeah.
Right. And the reason why this chapter is so long is that this is the area where I think people doing the creation evolution debates and dialogue have ignored the principle of being interdisciplinary. If you integrate, it's amazing how you can resolve a lot of the disputes that people have about the fossil record. A subtitle for this chapter would be Why the Fossil Record Looks the Way It Does. And you can't figure that out by only looking at biology or only looking at the fossils, the paleontology. You know, I demonstrate, for example, you need to look at chemistry, you need to look at geophysics, you need to look at astronomy. In particular, the physics of the sun plays a crucial role in our understanding why the fossil record looks the way it does and who or what is responsible for the originations or speciation events we see here on planet Earth.
All right, Hugh, in regard to that fossil record, some might say, boy, there seems to be a predominance of bacterial life. Why does God have that for so long on this planet?
Well, a lot of atheists and agnostics have made that point. They're saying God's responsible for the history of life on planet Earth. He seems to be dawdling with bacteria for a long, long time.
Yeah.
And indeed, for the first 3 billion years of life's history on Earth, that's all we see is bacteria and bacterial colonies or single-celled fungal species and colonies, really a simple life. And you say, why would that be the case? Wouldn't the Creator want to get human beings on the scene faster? What we discover is, given the laws of physics that God chose, and again, He's got many different reasons for choosing those laws of physics, you wind up with a planet, as ideally designed as planet Earth was, that nevertheless has its metal content essentially in soluble form, which would be deadly for advanced life. And so one of the roles of the bacteria, one of the reasons why bacteria predominate for so many billions of years, is that those bacteria are created by God and designed by God to transform the poisonous metals into a safe state for humanity.
What would be some examples of those metals?
Well, there's 22 metals in the periodic table that we refer to as vital poisons.
Mm-hmm.
An example would be chromium, for example, or selenium, or iron, copper, silver. Even arsenic is in that category, which means if you don't have enough of those metals in your body, you will die. But if you have too many of those metals, it will poison you. So it's critical that you have an environment where we have those metals in soluble form at highly fine-tuned abundance levels so that they neither kill you by not being abundant enough or kill you because they're too abundant. And we're talking fairly narrow ranges that are tolerable by advanced life. And so what God does, He creates a whole suite of bacteria. And what's fascinating is that there are different bacterial species that focus on different metals. So, for example, you've got bacteria that feed on iron. You've got bacteria that will feed on molybdenum. You've got bacteria that feed on copper and lead, zinc. And these bacteria work to transform, say, soluble zinc and put it into insoluble form. Now, there's two benefits for that. Number one, the soluble zinc quantity gets brought down to the just right level. And number two, the transformation process winds up producing very concentrated ore deposits of, say, zinc sulfide. And therefore, we can go around the planet today and find where billions of years of previous bacterial activity through the life and death of these bacteria has taken the very thinly distributed soluble zinc in the Earth's environment, collected it and concentrated it and into these ore deposits. You say, what makes the ore deposits? It's the bodies of the dead bacteria. So these bacterial mats will form, and they pull all this soluble zinc out of the ocean, and in their death, they fall to the ocean floor, but they wind up concentrated insoluble zinc on the ocean floor, which later becomes continental land masses, and we come by and mine the stuff, and we're able to launch human civilization.
Wow.
I seriously doubt if civilization would ever have been launched if it wasn't for the bacteria forming these ore deposits.
Well, busy little creatures, but I have much more respect than I did before hearing that about bacteria. Thank you, Hugh.
Well, there's more than that. I mean, what happens is that the Creator somehow steps in and doesn't remove these bacteria after they've done their job, but he brings them down to a just right level. Because if you take the bacteria completely away, then the soluble zinc again begins to build up. So it's important that we have a huge abundance of these bacteria in the past, then a just right abundance today to keep everything at an optimal, stable level.
So the amount of bacteria in Earth's history up to the present has been fine-tuned?
Fine-tuned every step of the way throughout the past 3.8 billion years.
Wow.
There's even bacteria that eat uranium.
Okay.
So you can imagine that.
Yeah, remarkable creatures. Hugh, you've been known about your ideas on the faint sun paradox. How does this paradox put competing creation-evolution models to the test?
Well, it's a way to put to the test theistic evolution, naturalistic evolution, young earth creationism, as well as our models. So it's a powerful tool because these models predict radically different things in the context of the faint sun paradox.
Each has a different perspective on it?
Each has a different perspective on it. So this is a powerful tool for putting to the test these competing models of creation evolution.
Okay, let's talk about it.
Now, the naturalists, for example, as well as the theistic evolutionists, have been presuming that the biology on the planet Earth over the past 3.8 billion years has taken place under constant physical and chemical conditions. And the physics of the sun proves definitively that that's not true, that the sun does not provide the Earth with a constant temperature environment. The sun early in its history loses about 15% of its luminosity. Then later on in its history, it gains back that 15% luminosity and is continuing that today. In the early history, it's losing its brightness because of its way mass is being stripped away from the sun. But there reaches a point where the sun stabilizes and stops losing mass in any significant way. But at that point, because of nuclear burning, hydrogen in its core is converted into helium, which increases the density of the core, which makes the solar furnace run even hotter. And so over the past 3 to 3.5 billion years, the sun has been getting progressively brighter and brighter and brighter. Now, the Creator, in my opinion, has taken care of that by making sure that he has the right life forms on the planet and the right abundance and the right diversity of the right type. So as the sun gets brighter, these life forms decrease the efficiency of the greenhouse effect in Earth's atmosphere. Basically work through two different mechanisms to remove carbon dioxide, water, and methane from the atmosphere, greenhouse gases, and put them into the Earth's crust as biodeposits or as sand and as carbonates. And consequently, as the sun's getting brighter and brighter, the Earth's atmosphere gets progressively less and less efficient in its capacity to trap heat from the sun. Therefore, the temperature of the Earth is maintained at a permanently ideal level